All right, welcome back. Okay, so now we're going to talk about hyperbolas again. And with hyperbolas, last time we talked about centered at the origin. Now we're going to, just like we did with ellipses, we're going to now generalize it more to hyperbolas that are centered pretty much anywhere. So h, k again. So we're going to say, okay, what if it's centered at some other point other than the origin? And so this is the summary table. So again, not much that we need to add to it. Just like with, again, we saw the same sort of thing with circles, right? When you're graphing circles, whether the circle is centered at the origin or whether it's not, right? We have this hk in there for a generalized location. And then we saw the same sort of thing with the ellipse, right? And ellipses. Now we're going to see the same thing with the hyperbolas. Okay, so whether the hyperbola is transversing the graph is transversing the axis of symmetry horizontally, or whether it's traversing the axis of symmetry vertically, will give us both of these columns. So here are the equations: the center, the foci, vertices, and the asymptotes, the equations for the asymptotes. So again, notice how we have a minus h and a minus k in here. So same general formula, we're just adding an h and k in there to tell us where the center is located. Okay, so again, make sure you understand that whatever variable is here, this is telling us the whether it's going to be traversing horizontally or vertically. Okay, so in this case here, it's horizontal because it's x. So think about the x-axis. Here it's y. So think about the y-axis. Okay, and so this is going to be your a squared. So the a squared doesn't change. Notice how the numerators change. Again, so this is a review. Okay, and let's see what else. So this is always going to be your a squared, and this is always going to be your b squared. And of course, the center, if it has this form, then the center is going to be hk. Also pay attention that these are subtraction. Okay, so again, make sure that when you're setting this up and you're trying to figure out where the center is, make sure you understand that you're looking at the standard form is with subtraction there. The foci is going to be h plus c. Okay, so it's going to be h plus c and h minus c, k. So those are where the foci are going to be located for this. So h plus c comma k and h minus c comma k. So again, all we're doing is we're taking the distance that the foci is from the center, right? That's what we're adding and subtracting to get it. So we're starting at the center, and then we're adding and subtracting the c value in the x direction. Okay? Now, if we're in the vertical direction, all we're doing is we're adding and subtracting c, the distance to the foci, in the vertical direction for the y, right? And then also similarly with the vertices, right? Vertices is all about a, right? The a is the distance from the center. So we add and subtract a from the x coordinate, which is h, and then here, if it's going in the vertical direction, we just add and subtract a to the y coordinate, which is k. Okay, and then notice the same thing with the asymptotes. All we're doing is we're adding an h and a k to the formula, to the equation. That's it. So before it was just y equals plus or minus b over a times x. Now we're just putting in the subtract k and the subtract h to generalize it. Okay, and then again, if it's a vertical direction, this is what it'll look like. So again, this is a table that you're going to want to know. You're going to want to memorize it. It's going to make things very helpful to you, especially when we do examples or you're doing the homework or on the exam. So we'll do some examples now.